की जो काउंसिल है दैट एसजी, उसके कुछ मेंबर्स अभी ज्वाइन नहीं किए हैं। कुछ है, हाँ, ये अहमद का मेरा मैसेज है। फाइनल प्राइस ऑफ 3.23 crore.
Yeah. So, good afternoon, everyone. Good afternoon and good evening and good morning also. So, first of all, I should thank our today's speaker, Ashutosh sir, for kindly agreeing to deliver his talk today. And so this is actually a monthly lecture series which we started as a part of TC220 field monitoring in geomechanics as the ISMG technical series. So we are having our 2026 conference on field monitoring in geomechanics, and this is the 12th conference in series which happens every 4 years. So that will be held in 2026 August in IIT Indore. And so as a part of curtain rising events, we started this monthly series activities. So this is the 7th lecture in the series. And I'm very thankful that our last 6 lectures are from different, people from practitioners and researchers from other parts of the country. And this is our first lecture from our country, so that is one good part I'm very happy to share. So our TC220 chairman, he just messaged that he'll be not able to join because of some travel and network issues. So this very brief information, introduction or like welcome address. So I'd like to ask Dr. AP to say a few words regarding our Indian Geotechnical Society and Dr. AP.
Yeah, good afternoon to one and all, and thank you, Neelima, for being able to invite Ashutosh sir to this lecture. And he is really a very experienced person, and working with he's having a lot of tunnel and underground structures experience and done a lot of work, and he's a known name in the field of tunneling, especially transport tunnel. So he's expert of that. So thank you, sir, for accepting our invitation and joining this this webinar series of webinar lectures. And regarding our conference, this conference at Indore, that is going to be organized in 2026. Before that, first Geotech Asia is going to organize. So a lot of international conferences are being organized, and IGS is quite active and transparent and visible also globally. So, and in our this effort, this lecture series will play a very important role as well as this conference. So with this, I congratulate Neelima for organizing this, and thanks to Ashutosh sir for delivering this lecture. So thank you very much.
Thank you so much, Dr. AP. So with this, I'll take a privilege to introduce our today's speaker, Ashotosh sir. And he is a civil engineer and graduated in 1988. And his professional journey started with a lecturer in Rajasthan Institute of Engineering and Technology, Jaipur. Subsequently, he joined, Public Works Department in the government of Rajasthan in 1991. And while his service, he pursued his master's in transportation engineering from MNIT Jaipur. And he's also, in part of several projects for several years with NHA, and he was a director at PIU Palanpur. And then he had a significant role in IL&FS, notably as a senior vice president and a regional head, Northern India. And in 2018, he transitioned to Brookfield, a Canadian infrastructure fund, assuming a role of CTO. And presently, since 2020, he serves as a COO at DRA Infra. And actually, our railway or highway tunnels started in country very recently. I can say 12 or 13 years before. Very recent. So I think DRA Infra has played really great role in building such kind of infrastructure for the country. So
Yeah.
his contributions in the infrastructure projects, especially highways, bridges, tunnels, is very notable, and his achievements is a completion of 9 tunnels he could do in the country, and which is including the longest Chennai Nashri highway tunnel also. And he's actively involved in advising to MOTH and on tunnel projects specifically. With this very brief introduction, sir, it's my pleasure to host you here as a part of TC220 of ISMG and IGS also. for this lecture series. And sir, you will be having a 45 minutes lecture, and then we can have some interaction with us participants. So over to you. Thank you.
Thank you very much for your kind words, especially Neelima ma'am and Singh sir. I think we have spoken a lot, but first time we are viewing each other on offline. Oh, sorry.
Yeah, sir. I have talked to you on phone also many times when we were handling the Kashmir project. Na?
Yes,
Mm.
yes. So,
And yes, sir.
yeah, go ahead, sir. So, just I would like to share my presentation, and I hope I'll be able to finish it in the given time. Is my presentation visible?
Yes, yes, yes. Kindly
Yeah,
make
it's
it full
visible.
screen.
Okay. So, actually, I'm basically a field engineer involved in tunnel construction, tunnel managing, and also subsequently the tunnel equipment installation. It includes the integrated tunnel control system. So my academic experience is very small in this field, or rather nothing compared to the faculty which I'm seeing here. So bear with me that I'll be able to, whatever experience I have in the field, would like to share it. And I'll start the content. Actually, I'll try to cover what is the need of the tunnel monitoring system, what are the instrumentation that is required to be monitored, what should be our criteria for selection of equipments, how the tunnel monitoring is important over not only during construction or prior to the construction, but subsequent to the construction during the operation. And this is applicable mostly for all underground structures. And in the end, we will talk about how the data collection is reported and a continuous monitoring record is created. These days, we are in the AI world, so I will talk a little about how the AI can be useful in our tunnel monitoring activities. It is a complex, of course, it is a complex, but it's a very, very vital component of the tunnel, both design and construction. And since the tunnel is an underground structure and we have a great responsibility on us to construct the safe structure and should remain safe during its operational life. We have seen many times during construction, nothing happens, and subsequent to the construction, there are accidents reported because of lack of subsequent monitoring during operation. So it's a very, very important. We should manage and operate tunnel with efficient monitoring and data interpretation. I try to divide the entire structure of the today's talk in around 40 odd slides, but we'll try to conclude. Most of the slides are having the pictures, so I'll try to finish it in 45 minutes, and subsequently enough time will be available for our discussions. What is the requirement of instrumentation? Actually, why?
Sir, sorry, your slides are not moving, and
Are not moving.
Yes.
yes, now it's showing content slide, but can you please make it full screen?
I was trying to make it full screen,
Okay.
but in full screen, I think becomes. Is it now moving?
Yes, it's moving.
Yeah. Okay. So why do we require the instrumentation, and where we started the instrumentation? Actually, if you will go to the earlier part of the tunnel construction, there were very few instrumentation that was installed. And as you are aware, before probably in India, as Madam said earlier, the transition point or the watershed movement of the tunnel construction, particularly in transport tunnels, was the construction of Chenani Nashri Tunnel. There were 3 projects awarded at a time in India, and these 3 were having almost same length. The Chenani Nashri is having 9.2, the Rohtang is about 8.9, and the Kazigund Banihal is around 8.5. So all these 3 tunnels awarded more or less in 2009-10, and the first tunnel which was completed in 2017, that was Chenani Nashri. Subsequently in 2021, the Rohtang tunnel, in 2022, the that Rohtang Kazigund Banihal. So when we started the tunneling, there was a concept in the mind of the planners that the tunnel is a very, very expensive structure, very, very costly. And at one point of time, the minister said during the breakthrough of the Chenani Nashri tunnel that in 200 crore per kilometer, you will be able to construct a kilometer tunnel. In 200 crore, I can construct 10 kilometer of highway. So it's very expensive. Its country would not afford it. But then I explained him that tunnel is a safe construction. It's the life cycle cost, if you will take it out for the tunnel, is very economical. We gave the example of Chenani Nashri, that every day you will be able to save 27 lakhs rupees on fuel cost alone, apart from the cost saving that will be there because of the accidents or the traffic remain closed during 10-15 days for snowfall or landslide. That's the cost which is indeterminate. But if overall that is given overall calculation of the cost, the internal rate of return for a tunnel project is around 22%. In 32% in this case, where in highways, the internal rate of return generally considered 16% as the best. So when I explained this, I think thereafter the changes started post 2017. And before 2017, there was another concept prevailing in India that also the tunnels are very, very risky because there is no proper control. Number one. Number two, it always takes very longer time. So tunnel projects are never completed on time. Believe me, earlier 9-kilometer tunnel, the NHAI or the ministry used to give 5-year to 6-year construction period. Now same 9-kilometer tunnel, these days, they are giving 3 years time, number one. Number two, when Chenani Nashri, we demonstrated on all these 3 tunnels, we demonstrated that the risk can be mitigated by a proper monitoring system, proper instrumentation. They have confidence now that the tunnel can be constructed safely, that too in time, within the cost. So now the scenario is changing, more and more tunnels are coming up.
Excuse me, sir. Sorry to interrupt you. Sir, am I audible?
Yeah, I can hear you.
Sir, actually, it's not in the presenter view. Can you switch to the presenter view? The slides are also not moving. You first right click on the screen on which you are.
Sorry?
Sir, please right click on the screen on which you are.
Yeah.
No. First, yeah, slideshow and then right click on the screen. Just a minute. The screen is not visible.
What to do? It is in the present.
Yes, sir. Now right click on the screen.
Yeah.
Yeah, and hide presenter view. There is an option.
Hide presenter. Okay. Oh, now it's full screen?
Yeah, now it's full visible.
Okay. So, coming back to the discussion I was having about the watershed movement in India for the tunneling. So in 2017, actually, the ministry started thinking about a lot of tunnels. And Presently, almost 1,000 kilometers of tunneling either under planning or implementation, or they are under bidding. Now, tunneling is considered as a usual construction, just like a flyover or a elevated corridor in the road projects, particularly in road and railway projects. Now, coming back to the today's discussion, what should be the criteria for selection of good instrumentation in the underground structures? First, it should be a reliable one, accuracy, resolution, precision, and drift. And also these days, one more thing which is important is whether it can be monitored in real-time basis. So instrumentation are now switching towards the real-time basis analysis and recording the data. So the another important aspect is, since the tunnel instruments are installed for a very, very long period of time, so the reliability should also include about the longevity of the instruments. And as I said, automation is now becoming part and parcel of today's tunnel monitoring. Most of the tunnels now in India, inbuilt provisions are there in the contract with regards to the real-time monitoring on your handheld devices, particularly in mobile phone or on your laptop. What is the purpose of the instrumentation? See, NATM design is a dynamic design process, wherein as you progress, you modify your design. As you see the tunnel, more and more, you improve your design based on certain criteria which has been given by the designer, based on ground support which you are getting. And initially, you just predict, but you correlate your prediction with the actual ground reality, and accordingly you manage your support system. Based on the support system, you also monitor the various stresses or convergences that are encountered in your tunnel while you are executing underground structure. So first is design verification. Now, during construction, it helps you to diagnose particularly where your weaknesses are and where actually the additional support or the structures we will see subsequently how we plot the data of the whatever monitoring we have done, or convergence data, and then we will see how we quickly correlate the subsequent what is going to happen and how we are going to control the previous one. A small monitoring failure can lead to the catastrophic event, just like we had some time ago in one of our projects in Uttarakhand, that Silkyara tunnel, wherein they were aware that the convergence limits are exceeding, but still they continued with the correction in the cross section, and ultimately leads to a catastrophic failure, and people were trapped in the excavated tunnel. The other purpose of the tunnel monitoring instrumentation is quality control, wherein you can assure that whatever the rock bolts or the let's go or short kits, whatever support system you have installed, or the lining you have installed, or the reinforcement you have installed, whether it is according to the requirement or not. So that quality control also can be taken care. Safety, of course, as I said, it is the main reason of providing more instrumentation in the tunnel. Apart from that, there are some regulatory requirement, like in many projects, what happened where there was low cover and there was a population sitting at the top of the hill, and when the tunneling agency was executing the work, they started reporting that we have faced the challenges, we have got the cracks in our buildings, the other problems they are facing. Their animals are scared. So in that case, the regulatory authorities now making compulsory that wherever there is a urban population at the top, you have to have a certain instrumentation, particularly like the measuring the whatever deflection or whatever vibration that are at the top of the hill. Now, performance, whatever you are doing, whether it is performing as per your expectation or not, you install the instrumentation, you record it, and check whether the system or whether the support system you have provided is sufficient or not, or whatever be the corrective measures that is to be taken. As I said, legal protection, when in one of the project we had the data we made available the data to the honorable court that the cracks which are there at the top of the tunnel is not because of the failure of the slopes, it is because of the other reason. We gave them the data, we installed the inclinometer and all at the slope of the open cut. Sorry. And now what should be the monitoring strategies? The overall objective of the technical monitoring is to support inspection and improving the knowledge on the structure behavior. Now, first of all, we must identify and verify what are the actual technical parameter of the tunnel before we decide our monitoring strategy. It is not necessary that all the instrumentation are required in every tunnel. You have to select some of the equipments available to monitor your tunnel, and what are the environmental factors that should be considered, the reactions which you expect that will come on the tunnel, the degradation of the tunnel support system, that apart from that, the detection of the structural defects that has come up. All these parameters help in deciding the monitoring strategy. Unfortunately, another part which I am right now pursuing with the government on various platforms is that we do not use to keep the repository of every tunnel. So if we would have the repository of the tunnel, then probably we do not require much investigation if we are constructing any tunnel parallel to that or any tunnel in that region. For example, we requested government at that time to create a repository for Chelani Nashri tunnel. They did not create it, that repository, and that data is available only in the hard copies and available at project only. Now they have now invited a parallel tunnel to the Chelani Nashri tunnel, and while inviting that, they appointed a new consultant, and he carried out all the pre-bid investigations, and government unnecessarily spent a lot, and still he is predicting something wherein he could have easily assessed what has encountered in the past in the previous tunnel excavation. So that's thing. And what are the typical instrument scheme of a NADM tunnel? We will talk about NADM tunnel more largely. My experience is basically in NADM tunnels in Himalaya as well as non-Himalaya region. So I'll talk more about the NADM and whatever be the equipments that are required for NADM tunnels. So this is a typical diagram showing most of the equipment that are used to be installed in the tunnel. We'll talk one by one in the tunnel instrumentation. First of all, for verification of the design, as I said earlier, whatever assumptions that we have made is to be accordingly ratified in the field by the data, and the design needs to be accordingly updated as you progress for the construction. Site investigations also involve some monitoring. Keeping generally what we are doing these days is whenever we are doing the geotechnical exploration, we used to install the instrumentation in those holes. So we get the instrumentation as well as we decide what are the pore water pressure, permeability, rock soil stability, etc. during the investigation itself. Construction control, of course, is the basic purpose. Now, what are the different components that needs to be monitored for an underground structure? First is portal, whether portal of the edit or the main underground structure. Portal is the outside portion or the slope cut portion, open cut portion. So that is first thing we used to monitor. And in India, my experience says that about whatever number of failures that I have come across, or because of my inquisitiveness to know about the failure, I have evaluated more or less 70 to 80% failures in the tunnels are at the portal itself. It is the most ignored part of the tunnel engineering. And in portals, generally people used to install as less as possible the instrumentation. But whatever these days, wherever I'm constructing the tunnel, I'm putting maximum instrumentation on the tunnel portals. Second, we used to monitor the face. What are the slope stabilization techniques that is to be decided based on the instrumentation that is to be done on the face. Next is tunnel longitudinally as well as along the cross section need to be monitored, and different instrumentation is required for the particularly in the main tunnel section, and then escape egress tunnel, and of course the cross passages. Now, what are the parameters to be monitored in the tunnel? The first of all, what is the load that is coming on the supports that is to be monitored? Closure or convergence, that's very important parameter, because the NATM is a as progress tunneling design method wherein you anticipated the least and then subsequently allow some convergence, and thereafter based on the convergence data you improve upon the support or increase the support to restrict the convergence. Similarly, rock ground pressure on the support, whatever be the pressure that are coming, what are the instrumentation that is required for that. Radial movement of the rocks in between in the tunnel or outside the tunnel around the support. Pore water pressure, because the water pressure we have seen the many failure, particularly classical failure of the Rohtang tunnel, wherein Siri Nala could not be properly judged, and that there was a puncture in the aquifer and lot of water ingress in the tunnel, and tunnel remained closed for more than a year and a half. So pore water pressure needs to be monitored, and then horizontal movement of the tunnel or the settlement of the support. Now we'll go how the convergence are measured and how the convergence are represented. Now, why to monitor, of course, and what are the instrumentation that we'll see one by one. So the convergence measurement is carried out with the help of targets. Targets are simply a prismatic or non-prismatic bifocal type target, which is mounted on the surface of the tunnel or on the slope of the open excavation bumps or benches, and then or the face of the rock, wherever you are seeing the open rocks, you mounted these targets, record the readings, and then individual target and all the target put together, you determine what are the how the convergence profile is changing outside as well as inside the tunnel. Both you plot it longitudinally as well as along the circumference of the tunnel or along the periphery of the tunnel. stress strain curvatures are differential with respect to the time also noted. So whatever convergence, that is a simple calculation, Cp is equal to d0 minus d1 dt. The reading noted at the initial while installing the support and reading noted at any given point of time, the difference of that is convergence, and this convergence may be negative or positive. The positive is always dangerous because it is coming inside. Negative sometimes you may ignore, but however you can't ignore it completely. Now, displacement history. Displacement history means you monitor over a longer period of time and then plot it. And it is not necessary that whatever be the convergence you are seeing will be a short time. For many other regions, this convergence at a given point of time may suddenly change. So monitoring should not stop once you have gone ahead of the tunnel. I mean, the classical example is the Tilcara tunnel, wherein the accident happened. Place was about 2 kilometers ahead of that particular location. So the monitoring, if would have continued, probably they would have noticed that there is a major change in the behavior of the convergence, and they could have immediately taken the preventive action. So over a period of time, there is a monitoring, and along the length of the tunnel, we should also plot how the behavior is changing along the length of the tunnel. I mean, for example, you are moving in this direction, but you keep on monitoring at each and every location and then plot it. Remove the why it is zero reading, because initial displacement you are allowing, and that is to be ignored. So over a period of time along the length, if you measure it and then plot it, you will be able to know what is the longitudinal deformation behavior of the tunnel, how the rock mass stiffness is changing over a period of time, and how the pre-displacement measurement prior to the support is to be taken care. So this is very important parameter that needs to be plotted, particularly the deflection curve. Now, if this deflection curve is plotted with respect to the time also, then you will be able to know what kind of geological changes that is happening in the tunnel. For example, if you will see, you get a uniform deflection in the tunnel, and suddenly there is an increase in the deflection and it is going back. It means there is some geological formation that has encountered, or the weak strata that has encountered in between your tunnel, which requires additional monitoring. If you plot it over a period of time and draw the trend curve, then you will be able to know that there is a weak zone and we should take care of that beforehand. Now, frequency of reading, whether we should take it daily, whether we should take it on weekly or monthly, depends on the type of the strata you are encountering, or also the otherwise these days we are having the instruments, general instruments, which we are putting inside the tunnel. Our real-time basis, they are taking the readings, but it is not necessary that all along you will install that. So you are still dependent on the optical targets, wherein a manual reading is required to be taken. And in that case, how the readings are spanned. So I have just drawn various type of instrumentation, along with whether we should take it on daily basis or we should take it on a desired frequency. This frequency depends on many factors, whether you are encountering displacement continuously, you are encountering the type of strata, or at the time of excavation, you got a soft rock, or you have a particular kind of dip or certain geological formation. It all depends on that. But if you monitor it, it is compulsory to monitor visual observation, displacement, stress settlement, or the cracks on a daily basis in the entire length. Whether you have constructed 3 km length, start daily basis from the beginning itself to the end. Now, next is, what are the instruments that is to be used? I have listed down some of the instruments. No, I try to include all the instruments which is required, but it is not necessary that all the instruments are required in every tunnel. However, load cells, rock bolt load cells, convergence meter, and the typical earth pressure cells are required in most of the tunnels, along with the prism and the total station. So the first and foremost, which is most common, is bireflex targets, which is required in most of the tunnel. It is along the periphery, maybe at 3 location, 5 location, 7 location, depending on the field engineer who is monitoring the tunnel, depending on the rock class, whether you are providing 5 or 7 or 10, and in that category, wherever you need some specialized or some cautionary, or wherever you require intensive monitoring, you provide a more specific prismatic type of targets. Very simple. Whether you install 3 or 4 or more number of instrumentation targets, both in heading and benching separately, or heading benching to a full face together, that depends on. And you require what, apart from target, you require a total station and a skilled surveyor who monitor on and the precision level of these robotic total stations should be very high. And accordingly, you require a very skilled surveyor to monitor all these, to record all the data. And then you present the data in the various forms for the different targets, as well as all target put together in a cumulative way. So these are the, and there are a lot of softwares which are available these days to plot the target data. And then you come to the next, there is another way to monitor the convergence, which is also very precise. You install the specific points, and then you place the digital tape extensometer all along the periphery in this direction, and then you record what is the change in the reading. This is another method, that is basic system, wherein you install, this is the basis system which is installed one in a completed tunnel. Then you required, you measure the spatial data all along the periphery in both X direction as well as Y direction. The entire data that is changing, it is taking place over a period of time. And sensors are installed. These are the sensors which are installed. So these sensors record the readings. Then you provide the load cells. Load cells may be a vertical wire type load cells, or S type load cell, or maybe a vibrating wire type load cells. Load cells basically takes the reading in electromagnetic form and convert it into a digital form, whatever be the stress that is coming on the steel section, whether it's a load, I mean, whether it's a lattice girder or rib or rock bolt or whatever type of support you are providing, how much load it is taking, and how, whether the support has been mobilized or not, whether you are getting higher stresses or lower stresses, that you can take care. Now, there is the type of load cell, which is CS type, means there is where you are getting directly on the rock bolt, you install it and then take the reading on rock bolt. It goes to the handheld reader and then you can plot it on the laptop through a software. Generally, software provided by the people who are manufacturing the load cells. Now, the another important aspect is the measuring the pressure which is coming on the support system, whether shortcut or whether in the lining, whatever be the pressure that is coming up, whether it is sustainable or not sustainable. So you provide the radial and tangential stress meters. These are the radial and tangential stress gauges that has been provided. It's look like this, and accordingly you take the readings and then you decide whether the shortcut thickness is sufficient, whether whatever designs that have been done, and you can optimize also. If there is no pressure coming, you are provided 250 shortcut, you can reduce it, or you are provided 2 layers of wire mesh, and apart from that you are changing the suppose that you can take the corrective action also, as well as you can optimize your design based on these readings. So it's quite helpful. Then comes to the rock mass monitoring. So first we saw how the rock bolt stresses are monitored. Then we saw how the support, particularly layered support systems, we have taken care. Now it is the rock, whatever be the rock you are putting, you are encountering, how the rock along its periphery is taking care of the load that is to be monitored. Then next is pore water pressure. Same way as you install the load cell, like this is hard rock, soft rock monitoring system that is installed. Same way you can install the vibrating geometer to take care of water pressure that is coming on the ground or inside the rock which is encountering around your tunnel. So biaxial stress meters are installed for different type of rocks, whether soft rock or hard rock, to measure the variations that are coming in the rock system, or what are the stress changes in the rock system beyond the tunnel. So this infrared system are also installed to check the large cavern, particularly in the large caverns, that the rock mass inside, beyond the cavern, how it is behaving and what are the stresses that is coming. So that you have installed it and how it is taking care. Similarly, this different sizes of the depth is to be determined based on the type of rock. So this is the one of the instrumentation is installed to check the stresses inside the rock. This is a multi-point stress gauge, which is measuring. It depends on the type of rock you are encountering and what are the readings you want and how important is the and how long you wanted to monitor it. Particularly, this is applicable in case of docks where you are constructing lot of dockyards, underground dockyards, like one of the dockyard constructed in eastern part of the country on a coast. I have visited that place where there is a submarine dockyard, and this instrumentation is done in extensive way in that. Yes. Then next part is data recording during construction as well as post construction. This is a handheld device which you take it readout device, and cable is installed, and then the data is taken into this, which that data is converted into a readable format or interpreted in a readable format through PC or laptop. This is the monitoring of tunnel portal. As I said, the first we have gone underground tunneling, then we considered the large cavern structures, and then slopes. In slopes, generally you provide the biflex targets, then you provide the inclinometer or extensometer. This is the extensometer, inclinometer, and then multiple bore log data, MPBX, is installed at different height. Take care of that. Then the next part is data collection and reporting. It's very important. It is very easy to collect the data, but data collected, reported, the data collected has to be interpreted properly and accordingly monitored over a longer period of time. So now these days, a lot of softwares are available readily in the market, wherein the data management can be done very effectively. In many of the tunnel projects, particularly RVNL, in railway projects, they are now making it compulsory for contractors to buy a platform wherein the data can be recorded and interpreted over a long period of time. So this is the data acquisition, data logger channel expansion module, wherein the entire data is kept, stored. And this is database. There are softwares which are available, wherein either you can download the app in your mobile or you can put it in the laptop and monitor the data. ARMS is one of the software which is web-based application. Now, apart from that, now if the data is available, particularly for the analyst and the researchers, the numerical modeling can be done very easily with the kind of instrumentation we will receive. Now, most of the tunnels, particularly apart from the data manually recorded, these days the authorities are making it compulsory that these data be made available online all the time and to everyone, so that one can easily evaluate how the future tunneling scenario will be. And finally, conclusion. So tunneling, first of all, the monitoring is there is no choice. There should not be any choice regarding monitoring in the tunnel. That's very clear. This is the first thing which has to be done on any of the tunnel project or underground project. Now, there should be a simple and easy mechanism to have the monitoring in the tunnel, so that everyone can easily understand the data as well as it can be easily interpreted. The technology should be synchronized with the latest time. Should not become that whatever be the instrumentation today you are doing will become redundant or obsolete after 5 years. So your technology should be long driven. You should select that, and whatever be the structural code that should be formed with regards to the tunnel monitoring. That's all. I conclude my talk here.
Sir,
Some of
thank you
the
so much. Sir, we are open for discussions.
Dr. Dhawan has raised
Yes,
how
yes,
to
yes.
ensure the durability, life of sensors, life of transportation tunnels, and type of sensors and their places of installation. Right, sir? So first of all, durability. Actually, there are good companies available in the market which gives the better material and the, of course, sometimes the cost becomes the criteria, but there are durable equipments which are available. And I know I'm monitoring, like just in dam monitoring system, the dam which were constructed 40 or 50 years ago, it's still, whatever be the monitoring system they have installed, it is still working. So I don't think durability is an issue, but yes, it should be a durable one. Life of the sensor, I think most of the sensors leave life is more than 30, 40 years until it has been damaged for one reason or the other. Life of transportation tunnel, the tunnel is designed for 50 years. If there will be any uh, other geological or tectonic movement in the ground, then only its life is under danger. But otherwise, in lot of old tunnels, by the way, the tunnel which was constructed at the time of Pandavas are still there in Uttar Pradesh near Hastinapur. It is still there. So the life of tunnel can be anything. And life of the type of sensors and their place, as I detailed earlier, that it depends on the type of rock, the type of strata you are encountering, and also depends on for what purpose you are constructing the tunnel. There is a tunnel which was constructed exclusively for VIP movement in particular region, and that tunnel has a lot of sensors, and there are a lot of instrumentation that has been done, which even in normal tunnels you never used to provide. So it depends on use, it depends on type of geology, it depends on area in which you are working. If it is a highly active area, particularly from the earthquake point of view, then you install more and more equipments. And if you are having a little less control on your quality of construction, then you require extra monitoring equipments. Please access the upcoming.
So, other participants, I don't think so. Any other question in our
there is a question from Kavi. Will there be any chance of instruments malfunctioning and will be replaced? Yeah, it can be replaced, and we are replacing also.
One of my questions which I left is Dr. Dhawan, how you will validate the design of such projects?
Sorry, sir, could not hear you.
How will you validate the design of such projects before construction?
So he's asking design validation.
Okay, design validation. Yeah, but right now Professor Neelima is visiting one of the projects, and she'll be in a better position to tell how validation is being done and how the validation sometimes becomes headache. Actually, the design validation is with the progress of the tunnel. And if you have a good instrumentation and you are doing the probe, you are doing proper boring during the construction of the tunnel or probing, you can do the little update in your designs. Also, based on the previous readings which you have noted in the earlier construction, means the construction before that, you can interpret your results and you can discuss it with the designer. What are the factors he has considered in design, and those factors can be modified at a later stage, and accordingly the designs can be improved. Am I right? Probably this is what your question is.
My only as a civil engineer is that the proper geophysics investigation, proper geological investigation, and proper geotechnical investigation. I mean, we need to have the totality. There cannot be shortcuts. So, as per your vast experience in this underground construction, you have got any checklist or manual where see, because underground structural prediction is very, very difficult because see, we knew the expertise of geophysics, geologists, geotechnical investigation, underground water and unforeseen. So, based on your long experience, do you have some, checklists that these are the important things that you need to undergo before deciding the alignment and the type of construction?
Right, sir. Sir, as far as my experience is concerned, honestly, uh, I have yet to find a tunnel wherein all the geophysical, geotechnical, and geological investigations were completed before the award of the or the commencement of the project. There are very few. Now there is a limitation of the geological or geotechnical investigation or geophysical investigation. And you have a cover more than 1,000 meters, what will you do? I mean, how will you assess that? That's also a limitation. Having said so, but before the start of the project, most of the uh, builders or the developers are doing extensive investigations, and accordingly they are adopting it. They are not relying on the data which has been provided at the time of project preparation. They themselves are investigating, re-investigating, and ensuring their mobilization according to. But yes, no one can ensure, but there is no shortcut to investigation also.
So there is any other question from the participants, kindly unmute. And just to add to whatever Ashutosh sir said, I think we need to have an SOP, right? So I think NHI should work on making a SOP sort of thing for investigations and design, also for monitoring. Since that is not there, like there are a lot of mismatched things.
Yes. In fact, more important is lesson learned from the failure. That also should be documented.
Failure documentation, though, we are very, very not so good. So yes.
Our law does not allow me. I'm very honest and blunt on that count, sir. Failures never reported in India. It is reported only when it comes in the media. Otherwise, it is not reported. The Silkyara, whatever has happened, is not for the first time in India. It has happened. It had happened in many cases in the past, and I am a witness to it. I was involved in one of the, or rather, I was in charge of the project wherein there was a collapse was there, and we rescued the people. Of course, we rescued the people, but it happens. I mean, this time the media was very strong, and also we were having a lot of awareness about the social media. So people came to know about Silkyara. Otherwise, other incidents are unnoticed. The second thing is the tunnels are generally constructed in the remote location, and on those remote locations, the access is limited. So it remains unreported. Very few incidents in NHPC. We were trying to study in one of the. I'm a chairperson of the SOCHM Underground Council, and we were trying to collect the data of the various failures in various tunnels. Believe me, we were not able to get it from NHPC or NHAI or NHIDCL or BRO. The data. There is no repository. There is no collection of data. Even the papers are limited. Papers are published on the failure. Even in one of the tunnel project, I went to the China also. In Chongqing, there was a tunnel failure. We were not allowed to get the data. So it is not only in India. You will get the data only for the tunnel failure in Europe mostly, but not this part of the world.
What type of arbitration disputes, you have come across during your long working in NHA and other places.
Sorry,
Because,
sir.
see, sir, what type of disputes, arbitration disputes?
Oh, disputes. Sir,
Right.
in tunnel, so you have touched an interesting point. Actually, in 2019, we gave a presentation to Honorable Minister along with the NHI Chairman, NHI DCL Chairman, MD, DRO, DG, and Secretary MORTH, wherein we said that in tunnel projects, we are, as a contractor, we are getting a lot of issues. Number one. Number two, it costs you very high, because if you will not be giving the complete data, you assume certain risk in every project. Let's say, in general, if there is no metrics is available, we used to consider that there is a 25-30% change in the rock class and support cost will increase. Accordingly, we used to build in the contract. So in 2019, we gave this presentation that you make the GBR as a compulsory part of the contract. You will come out of many disputes which has already come up. It is only one reason the dispute comes in the tunnel project. It is because of the wrong DPR. And every time the NHA used to say, or the authority used to say, that DPR is not part of your contract. Therefore, we cannot give any compensation towards the time and towards the cost for the project. And it leads to the dispute. It goes to arbitration and courts and everywhere. To minimize the dispute and to have a proper costing of your tunnel project, you should make the risk sharing metrics as part of the contract. And I'm very proud to say that the first trial of the risk sharing metrics was done in Jojila project, wherein the government saved huge money, because the bidders used to come down drastically their bids, because they were aware that if there will be any change in the rock class, they'll get the money. So government saved huge money. The project is running very on time, and probably it is a very good progress, because he knows he has a less risk to take. Right now, I'm executing one of the project in Orissa, and also the 7 tunnels in JNK we are executing. We have found that there is a drastic change in the rock class which has been given in the DPR, but there is a matrix available wherein there is a formula which is given that how the cost compensation will be there to the contractor and how the time compensation will be given to the contractor. So, and NHI and the other authorities are compensating them. There is no dispute. The contractor is aware, and we quoted accordingly. Earlier, in earlier days, the tunnel costing in Himalaya, generally 2-lane tunnel, was around 150 to 200 crore rupees per kilometer. Now it is 70 crore to 80 crore rupees per kilometer. Technology is same. Drill and blast is still NATM is same. There is only one option, one liberty, that is to the contractor, is that he can design his own support system, number one. And number two, if there is any change in the geological parameter during the execution, the authorities will compensate. That has reduced the costing. And believe me, whatever be the compensation NHI is going to give for these changes, which will be much lesser than what would have been the tender premium that would have been included by the contractor, considering those risks. So, main reason of the dispute ever that has come in tunnel project was the geological and geotechnical investigation, which were not matching with the bidding document. That has, to some extent, has been resolved in the present context.
The DPR is the major concern.
Sorry?
DPR is the major concern, I guess.
No, you see, ma'am, if you have a little less reliability on DPR, you are aware that the DPR is faulty. I may have to end up paying some compensation, but you know it in the beginning itself. Now, earlier DPR was faulty, contractor was not given the compensation, project he was lingering on, he was aware that this rock is not supporting me, so I'll go slowly, I will not unnecessarily put in my cash flow into that. And since I'm not going to get it reimbursed, I will make the reason, one reason or the other, will find out the faults in the contract and will start making the claim.
So not
Now
only
that,
canal projects, actually, even dam projects. I mean, with my experience, DPR, whatever they give in the DPR, not match at the site also, because we
yeah,
also
yeah,
have a couple
that's
of
right.
projects in Rajasthan. So dam sites also, yeah.
Yeah, that's right. That's right. See, we give very small time to the consultant for designing the project, whereas we give a lot of time to construction. 1 year, 6 months to 1 year is the time which is given to any consultant. I'll give you, this is apart from geotechnical. A minimum parameter required for any ventilation in the tunnel system is the differential pressure between the two portals.
Department. These EPC contracts, are they helping the department?
EPC contract? Sorry?
I think
Engineering, are they helping EPC contracts? Are they helping the department to, get success?
Yes, I can
Reducing
say firmly,
the-
sir. Yes, yes. I think this is a point wherein the contractor is a contractor. He is not there for charity. He is there for making the money. And if he expand the expect to be put in. So if your DPR is weak, probably contractor will take advantage of it. And there is no doubt about it. I have worked in all roles. I have worked as a developer, as a asset acquisition, as a government employee, or as a government officer, and also now as a contractor. So I know all the areas, but you can barricade your contract conditions very well.
also academician.
Yeah, also a academician sometimes.
Sure. So thank you so much, sir. And I request the participants, if you still have questions, I can share the Ashutosh sir email, and please feel free to write to him. Sir,
Sure.
thank you so much for such an informative lecture. I am so happy to listen to you. And if there is no more questions, this lecture is being recorded and it will be uploaded in our IGS YouTube channel. Kindly subscribe that. Most of the things we are trying to make our, digital library sort of depository. Then second thing is it will also be posted on ISMG TC220 YouTube channel. Both the places you can find this. Whatever the updates that if you want to have it on field monitoring, so please follow
you.
our lab and also the LinkedIn profile of TC220. So the details have been shared in the chat box. And also please follow our conference website also. I would be very happy to host you, not only in 2026 anytime. So please visit IIT Indore if you are coming. Thank you so much, everyone. And Dr. AP, you have anything to say?